Hello students, welcome back to our channel. Today in this video we are going to see Tamil Nadu State Board syllabus, Class 12 Physics, Unit 2 Current Electricity, Derivation number 10. Today we are going to see the 10th derivation. This is the part 10 of this video series. Come on, let us continue with our studies. Find the current when cells are connected in series and parallel. So, today we are going to see the expression for current when cells are connected in series and then when they are connected in parallel. Answer. First one, cells in series. Have a closer look at this diagram. Here, there are 4 cells connected in series connection, and this epsilon are the EMFs of the respective cells, and they have connected to a resistance R. This is the diagram you are supposed to draw when this question comes, and the current flows from positive to negative, which is nothing but the conventional current. Now let us see the explanation. Explanation: small r, internal resistance of the cell, then epsilon, EMF of the cell, capital R, external resistance, small n, number of cells in the circuit, capital I1, current produced by a cell. This I1 is nothing but the current produced by a single cell. Now let us see what is total EMF. Epsilon is the EMF produced by a single cell. For example, if there are n number of cells in that circuit, then the total EMF is n epsilon. Then what about total resistance? For example, here there are 4 cells. If there are n number of cells, then each and every cell has an internal resistance small r. So total internal resistance is nothing but n into r plus the external resistance capital R. This expression gives the total resistance. Therefore, current I is equal to, from Ohm's law we know that V is equal to IR. Therefore, I is equal to V by R. Here in the place of V, we have written the total EMF N epsilon by, in the place of R, we have written the total resistance NR plus R. Here a condition arises. If the internal resistance small r is very small in comparison with the external resistance capital R, then we can neglect the term NR from this expression. Then we'll get an expression for I is nothing but N epsilon by capital R. We have removed this expression N small r as R is very less in comparison with the external resistance. Now the expression for current capital I becomes N into I1, because I1 is equal to epsilon by R. So in the place of epsilon by R, I have written I1. Therefore, current is useful. Why it is useful? Because the total current produced by this circuit is equal to N into I1. I1 is nothing but the current produced by a single cell. If there are 5 cells, then the total current is nothing but 5 into I1. So we get a useful current in this connection. So therefore current is useful. In the next step, if I is very greater than capital R, in this case we need to remove the expression where the capital R comes. So the expression for I becomes N epsilon by N small r. Here this n and n get cancelled. So we get I is equal to epsilon by r. Epsilon by r is nothing but I1. So I is equal to I1. Because I1 is equal to epsilon by r. In this case, the current is not useful. This current is not useful because though many number of cells are connected in series connection, the total current is equal to the current produced by a single cell only. So no matter how many cells we connect in this series, we don't get enough amount of current. So this current is not useful when small r is far greater than capital R. Now let us go to cells in parallel. Here comes the circuit diagram. Here there are 3 cells that are connected in parallel and altogether they are connected with external resistance R. And here also the conventional current flows from this positive terminal and it comes and ends in the negative terminal. So this is the circuit you are supposed to draw for cells in parallel. Now let us see the total EMF. Here total EMF is equal to epsilon. That's all. Though there are 3 cells connected in this connection, total EMF is equal to the EMF of a single cell only. Then what about total resistance? Total resistance is equal to small r by n plus capital R, which means if there are 5 cells in the circuit, then we need to divide the internal resistance of a single cell, that is small r, by the number of cells, that is r by n. And again we need to add the resistance of the external resistance. So total resistance is equal to small r by n plus capital R. Therefore current I is equal to epsilon, that is total EMF, that is epsilon by total resistance, which is nothing but r by n plus r. In the next step, I is equal to epsilon by, we need to take LCM, so we get, we should multiply this n with r, then we need to write n as common, so epsilon by r plus nr by n we get. In the next step, if this term goes this side, it gets multiplied by the reciprocal of this term, so we get n epsilon by r plus nr. So this is the final expression for current I. Now let us see the condition. If r is very smaller than capital R, if small r is very smaller than capital R, then we need to neglect this term from this expression. This term, as r is very negligible, this small r can be removed from this expression. So we'll get I is equal to n epsilon by n capital R. N and n get cancelled, so I is equal to epsilon by r. In the next step, we all know that epsilon by r is nothing but what? I1. So I is equal to I1, as I1 is equal to epsilon by r. This current is not useful. Though there are many cells connected in this connection, the total current is equal to the current produced by a single cell only. Therefore, this current is not useful. Then what about the next condition? Here comes the next condition, that is, if small r is far greater than capital R. In this case, we need to neglect the term capital R. So what do we get? We will get the expression like this. I is equal to n epsilon by small r. We all know that epsilon by r is nothing but I1. So I is equal to n into I1. Here this current is useful because as many cells we connect in this connection, we get more and more current. So the amount of current produced in this connection is directly proportional to the number of cells connected in the circuit when the condition is of this kind, when small r is far greater than capital R. Therefore, this current is useful. Now we are going to sum up the results what we have found so far. Series connection of cells is advantageous. That is, series connection of cells is beneficial. It gives benefit to us only when the internal resistance of the cells is negligibly small. So in the case of series connection, the internal resistance of the cells must be negligibly small. That is, they must be negligibly small in comparison with the external resistance capital R. But in the case of parallel connection of cells is advantageous only when the external resistance is negligibly small. That is, capital R is far smaller than small r. So in the case of series connection, internal resistance must be very, very small. But in the case of parallel connection, the external resistance must be very, very small in order to get a useful current. So with this video has come to end. Let us continue our studies with another video in the next session.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.